Hello students. Welcome back to KnowledgeHeals, your trusted guide for learning mathematics in a simple and fun way. Today, we will solve exercise 3.1 from chapter 3, Trigonometric Functions step by step. In this lesson, we will cover converting degrees to radians and vice versa, understanding arc length and how it relates to angles, solving problems involving revolutions and radians, applying the concept of radians to real-life problems. So, without wasting any time, let's get started. Our question 1 is convert degrees to radians. Convert the following degree measures into radian measures. First is 25 degree. Second is minus 47 degree, 30 minutes. Third is 240 degree. Fourth is 520 degree. We will see our first step of solving problem. Let us understand degrees and radians. A degree is a standard unit for measuring angles. A radian is another unit for measuring angles, where 1 radian is the angle subtended by an arc whose length is equal to the radius of the circle. Formula to convert degrees to radians is theta in radians equal to theta in degrees into pi by 180 degree. Let's focus on our first question, that is 25 degree. We will simply multiply with pi by 180 degree, which is equal to 25 pi by 180, which is equal to 5 pi by 36 radians. Second question is convert minus 47 degree 30 minutes to radians. First we will convert 47 degree 30 minutes into decimal format. Since 30 minutes is equal to 0.5 degrees, it will become 47.5 degree. Now for converting into radian, we will multiply minus 47.5 degree into pi by 180, which is equal to minus 47.5 pi by 180, which is equal to minus 95 pi by 360, which is equal to minus 19 pi by 72 radians. Now we will convert 240 degrees to radians. Here also we will just multiply by pi by 180, which is equal to 240 pi by 180, which is equal to 4 pi by 3 radians. Fourth question is convert 520 degree to radians. Here the same thing, just multiply by pi by 180, which is equal to 520 pi by 180, which is equal to 26 pi by 9 radians. Now we will convert the following radian measures into degree measures. First is 11 by 16. Second is minus 4. Third is 5 pi by 3. Fourth is 7 pi by 6. Explanation. Understanding the concept. If 1 radian is equal to 180 by pi degrees, then to convert radians to degrees, we multiply by 180 by pi. Formula. Theta in degrees is equal to theta in radians into 180 by pi. Let's solve our first question 11 by 16. First we will multiply by 180 by pi into 11 by 16, so it can be converted into degrees. As we simplify, we get 45 into 11 by pi into 4 degree. So we get 45 into 11 into 7 by 22 into 4, which is equal to 315 by 8 degree. It becomes 39 into 3 by 8 degree. As we convert, it gets 39 degree plus 3 into 60 by 8 minutes. We get 39 degree plus 22 minutes plus 1 by 2 minutes. Hence the final answer becomes 39 degree 22 minutes 30 seconds. Now we will convert minus 4 radian to degree. We can do that by multiplying 180 by pi to minus 4. As we simplify, it becomes minus 229 into 1 by 11 degree. As 1 degree is equal to 60 minutes, so it becomes minus 229 degree plus 1 into 60 by 11 minutes. Then it becomes minus 229 degree plus 5 minute plus 5 by 11 minutes. At the end we get solution minus 229 degree 5 minutes 27 seconds. Now we move forward to our third question, that is 5 pi by 3. Now we will convert to degree by multiplying 180 by pi to 5 pi by 3. In the last we get 300 degree as answer. In the same way we will do it for 7 pi by 6. We will just multiply 180 by pi to 7 pi by 6 is equal to 210. Let us move to our question 3. Small blue diamond a wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? Let's see our solution. As we can see, 1 full revolution is equal to 2 pi radians, and 360 revolutions in 1 minute means 6 revolutions in 1 second. White right pointing backhand index solution. So now it's easy, we can just multiply 6 into 2 pi, which is equal to 12 pi. Final answer, 12 pi radians per second. Now we will move to question 4. Find the degree measure of the angle subtended at the center of a circle of radius 100 centimeters by an arc of length 22 centimeters. Use pi equal to 22/7. As we can see the solution. Consider a circle of radius r unit with L unit as the arc length, which subtends an angle theta radian at the center. Theta is equal to L by r. Here, r is equal to 100 centimeters, L is equal to 22 centimeters. Theta is equal to 22 by 100 radian is equal to 180 by pi into 22 by 100 degree. It can be written as is equal to 180 into 7 into 22 by 22 into 100 degree is equal to 126 by 10 degree. So we get is equal to 12 into 3 by 5 degree. Here, 1 degree is equal to 60 minutes. So answer is 12 degree 36 minutes. Now we will move to question 5. In a circle of diameter 40 centimeters, the length of a chord is 20 centimeters. Find the length of minor arc of the chord. Now we move forward to our solution. As we see the dimensions of the circle are diameter is equal to 40 centimeters and radius is equal to 40 by 2 is equal to 20 cm. Consider ABB as the chord of the circle, i.e., length is equal to 20 centimeters. Now you can see the circle diagram, in which a triangle is formed with chord AB. In triangle OAB, radius of circle is equal to OA is equal to OB is equal to 20 centimeters. Similarly, AB is equal to 20 centimeters. Hence, triangle OAB is an equilateral triangle. Theta is equal to 60 degree is equal to pi by 3 radian. In a circle of radius r unit, if an arc of length L unit subtends an angle theta radian at the center, we get theta is equal to 1 by r. Pi by 3 is equal to chord AB by 20, then it becomes chord AB is equal to 20 pi by 3 centimeters. Therefore, the length of the minor arc of the chord is 20 pi by 3 centimeters. Now we move to question 6. If in 2 circles, arcs of the same length subtend angles 60 degree and 75 degree at the center, find the ratio of their radii. Here the solution are. Consider R1 and R2 as the radii of the 2 circles. Let an arc of length L subtend an angle of 60 degree at the center of the circle of radius R1 and an arc of length L subtend an angle of 75 degree at the center of the circle of radius R2. Here, 60 degree is equal to pi by 3 radian and 75 degree is equal to 5 pi by 12 radian. In a circle of radius R unit, if an arc of length L unit subtends an angle theta radian at the center, we get theta is equal to L by r, L is equal to r into theta. We know that L is equal to r1 into pi by 3 and L is equal to r2 into 5 pi by 12. As we keep doing calculation and simplifying, it becomes r1 by r2 is equal to 5 by 4. Therefore, the ratio of the radii is 5:4. 7. Find the angle in radian through which a pendulum swings if its length is 75 centimeters and the tip describes an arc of Length. First question is 10 centimeters. Second question is 15 centimeters. Third question is 21 centimeters. Solution. In a circle of radius r unit, if an arc of length L unit subtends an angle theta radian at the center, then theta is equal to 1 r. We know that r equal to 75 centimeters. First question is L is equal to 10 centimeters. So we get theta equal to 10 by 75 radian. By further simplification, we get theta equal to 2 by 15 radian. Second question is L equal to 15 centimeters. So we get theta equal to 15 by 75 radian. By further simplification, theta is equal to 1 by 5 radian. Third question is L equal to 21 centimeters. So we get theta is equal to 21 by 75 radian. By further simplification, theta is equal to 7 by 25 radian. Clapperboard, I hope you found this video useful. Don't forget to like, share, and subscribe to KnowledgeHeals for more mathematics solutions. See you in the next lesson.